In last lecture, we have started our third unit, okay? Introduction to SQL, okay? I share my screen first. Hope so the screen is visible. Is it visible? Hello, screen is visible? Yes. Hello, are you there? Screen is visible or not?
Yes, ma'am.
Okay, fine. We saw the overview related to the SQL. After that, we have seen the SQL language has a several parts, DDL, DML, as well as the view definition, transaction control, embedded SQL, and dynamic SQL authorizations. These are the several parts comes under the SQL. After that, we saw the concept of the SQL data definition. SQL data definition language is used to create a relation with specified schema to create a table, database. We are using the commands which comes under the data SQL data definitions. Okay. So let's move to the next concept, that is the SQL data types. Okay, SQL data types. As we know, if we are learning any technical language like C, C++, Java, in that also we learn the concept of the data types. Okay, to store a data, we required there are different kinds of data available. Okay, integer, floating point, character, strings. So according to their types, we are categorized that into a data types. Okay, so like that, SQL is a one kind of language to communicate with the database. So SQL also provides the built-in types. SQL standard supports a variety of built-in types, including first one is the character, and in bracket n. This is the syntax to show we are using the character data type. We are declaring the character data type. Here, character in bracket n, which represent it's a fixed length of character string with user specified length, that is the n. Suppose you want to store the 5 number of character as a single field, then you mention specifically character with n. That means the length of the character should be fixed, that is the 5. The full form of that is the character and can be used instead as a character for char. Okay. फिक्स लेंथ आपल्याला कॅरेक्टर डेटा टाइप डिक्लेअर करायचा आहे म्हणजे 4 5 तर आपण कॅरेक्टर यूज करू. देन var char in bracket n means now char is a fixed length, but sometimes we requires the variable length character strings, because we want to store the name of the students. The length of each and every name of students should get vary person to persons. So at that time we are using the var char, that is the character varying. Okay, it provides the facility to change the flexibility variable length. Okay, a variable length character string with user specified maximum length is n. If you are declaring var char and in bracket 20, that means we can store the maximum length of the character should be a 20, that is the 1 to 20. Okay, but not more than 20. We can't store more than 20 character length string. It may be a 10, 15, 16, 9, from 1 to 20, but not more than 20 if we are declaring character in bracket 20. Simultaneously, please note down these concepts. The next data type is the integer. It's one of the familiar data type. That is the integer. To store the integer value, we require the integer data type. And the verb, here we are declaring int, and it's equivalent to integer. Then small int. You learn the concept of the short int. Hope so in C language. Like that, over here just name get changed. That is the small int. As the name suggests, a small integer machine dependent subset of the integer type will get stored in this. Means internally whatever the storage is required, it's smaller than the as compared to the integer one. For example, for integer we require the 4 bytes, the small integer may require the 2 bytes, like that. Then numeric. Next one is the numeric. P in bracket D. Here a fixed point number with user specified precision. P is a fixed point number with user specified precision, and a number consists of P digits. Okay, with includes the plus sign too. Means you want to specify the some decimal point, number with decimal point, then P is a fixed digit, P digits with plus sign, and D is the decimal points. Okay, for example, we are declaring the numeric 3, P is equal to 3 as and D is equal to 1. Means 3 means over here, our left hand side at the decimal point, we can apply the 2 digits with plus sign. That means 1 digit is required for the sign. Okay, that is, for example, 44.5, 32.1, like that. You can store if you declaring numeric 3.1. But suppose you want to store 3 digit at left hand side, then it's not possible for this declaration 3,1, because one digit is required for the to declare the sign. Okay, so suppose for example 444.5, so it's not possible 444.5, because we are declaring 3 value as a value of P. Okay, so it's not possible because we require to store 1 digit for a sign. Okay, and dot 5, dot 5, yes, it's correct, but left hand side is not correct. Then or next 0.32, in that 0.32 at decimal point crossing is there, we are declaring 3,1, means we are only take a 1 decimal point for this example, and 0.32 will not get fixed that in that declaration. That's it's also not store that one exactly. Okay, numeric, are you getting the numeric? P comma D. P declares the number, fixed point number at left hand side, as well as comma D declare the decimal point. Okay, the next one is the real, double, as well as the precision. Suppose you want to declare the floating point double precision number with the machine dependent precision, then you can use this kind of data type. The next one is the float. In bracket n, a floating point number with precision of at least n digits. Okay. At that time, we are using float in bracket n. These are the standard data types which is supported by the SQL. Okay, standard built-in data types. Just note it down. Now, next one is the integrity constraint. Integrity constraints are a set of rules. Okay. Take any example of any organizations. If it is a standard one, that means it follows some kind of rules. Okay. We have to apply some rules and regulations. Okay. To maintain the quality of our organization's product. Okay. So like that, to maintain the quality of information in database management system, we have to apply the rules on our database. Okay, that's called as the integrity constraint. Okay, we are on the next point, that is the integrity constraint. These are nothing but the set of rules, and it is used to maintain the quality of the information. And integrity constraint ensures that the data insertion, updating, and other processes have to be performed in such a way that data integrity is not affected. Okay. We are applying the some rules. For example, if, on columns, that is on attributes, we are applying some rules. For example, if particular column should only uh, taking a character value as its record, and someone entering integer values, and that should not be allowed. Like that, we are applying some norms. Okay. Thus, integrity constraint is used to guard against the accidental damage to the database. Okay. Are you getting the concept of the integrity constraints, or may I repeat? These are the set of rules which we are applying on entities, domains, okay, keys. Yes. Are you getting the concept of the integrity constraint? These are the set of rules.
Yes, ma'am.
Okay. And it is required to maintain the quality of information. Then there are basically 4 types of integrity constraint. Okay. First one is the domain constraint, entity integrity constraint, referential integrity constraints, as well as the key constraint. Okay. Just notice down domain, integrity constraint, as well as its types. Let's see each and every one individually, one by one. First one is domain constraint. Domain constraints can be defined as the definition of a valid set of values for an attributes. If you are applying some rules on the attribute, that comes under the domain constraints. For example, over here, the student's record with ID, name, semester, and as well as the age is present. And that means ID means we are accepting only digits. Name, that is the character. Then semester as well as the age. Then the data types of the domain includes the string, character, integer, time, date, currency, etc. The value of the attribute must be available in corresponding domain. Suppose someone entering age with character value. So is it the valid record? No, not at all. So that kind of record should not be allowed. Because age is an each and every time is an integer attributes. So means we are while designing our schema, we are applying these kind of norms on our attribute. That is nothing but the domain constraint. Rule number 4, mute yourself. Are you getting the concept of the domain constraint? Yes, we are applying the norms constraint on the attributes. Okay. The next one is, just note it down first. Next, the second one, that is the entity integrity constraint. That means we are applying the constraint rules on an entity. The entity integrity constraint states that the primary key value can't be null. See, we all know the concept of the primary key and purpose of the primary key. To uniquely identifies our records, we applying the primary key. Okay, and if it is null, then can we apply the primary, can we recognize our records uniquely? No, not at all. Okay, some fields within a employee ID, for example, employee with employee ID, employee name and salary. And suppose employee ID is empty, then that record can we identify uniquely? Not at all. So in entity integrity constraint, it states that the primary key value can't be null. Please note it down. This is because the primary key value is used to identify the individual row or in a relation, and if the primary key has a null value, then we can't identify those row. Of course, na, if more than one records like these type, then how we going to be recognize these in a unique way? So the table can contain null value other than the primary key fee. Yes, of course, other than the primary key, in a table they can contain the null value, but the field, the attribute which has the primary key, that should not be null. Okay. See over here, employee in employee relation, employee ID at the end, if it is a null, that should not be allowed as it is a primary key. Okay, note it down. The next one is the referential integrity constraint. Yes, entity integrity constraint are on single table. Then the referential integrity constraints is it's specified between the two tables, because sometimes primary key of one table can be a foreign key of another tables. At that time also we have to apply some norms. I will repeat, primary key of one table may be a work as a foreign key in another table. At that time when we are referring that kind as a foreign key, then we have to apply the referential integrity constraint. A referential integrity constraint is specified between the two tables. This is the one of the important concept, two tables. In a referential integrity constraint, if foreign key, okay, in a table 1 refers to a primary key of a table 2, okay. Suppose concentrate now on these two tables, table 1 and table 2. In a table 2, D number, that is the department number in a table 2, over here. The department number is a primary key and which is worked as a reference or a foreign key in a table 1. Okay. Now, if a foreign key in a table 1 refers to a primary key of table 2, then every value of a foreign key in a table 1 must be null or be available in table 2. I will explain in detail. See, in table 2, department numbers are present 11, 24, 30. Okay. And we are in table 1, department number work as a foreign key. So no, the record with 11, no problem. The record with second 24 or 24, there is a no problem, because that record also available in a table 2. Okay. But the next record, that is the 18, whether is it available in table 2? No. So at that time, it's not allowed, because that record, it's not available in table 2 and it's not allowed as a data. Department number 18 is not defined as a primary key of table 2, and table 1 department number is a foreign key defined. So that's fine. It may be a null or it should be defined in a table 2. Okay, foreign key also may be null or it should be defined, but it should not be anything which is not present in a table 2 over here. Okay, that is nothing but the referential integrity constraint. Note down this third integrity constraint, that is the referential integrity constraint. The next one is the key constraint. A key constraint, that means we are applying the constraint rules on a keys. Keys are the entity set that is used to identify an entity within its entity set uniquely. Primary key, like that. An entity set can have multiple keys, but one key will be the primary key. A primary key can contain a unique and null value in the relation table. Then that is the key constraint. Over here, see over here. In 1002 and 1002, is it the unique record? Just a minute. It cannot contain a unique, the primary key. A primary key can contain a unique and cannot contain one null value in a relation table like this. We have to read. Okay. See over here. This is the record. Over there, 1002 and 1002. This is the duplication of the records is present in a ID, which is a primary key of these tables. And this is not allowed because all row must be unique. Okay. All these are about the integrity constraint. Okay.